Hello, this is Lady Tahila from the Coven of the Open Mind, Elder of the Open-Minded Path, and you're watching Metaphysics 101. Hail and welcome. The topic this time is on the expanding universe, and this is kind of like the cosmology side of understanding how the universe is one, the unification of all things. So I wanted to just take a moment to talk about where we're going with all of this. I feel like so far we've just talked about little aspects of physics, and I wanted to just reassure you that we are going somewhere. In physics, there's the theory of everything that is kind of like just explaining why, the similarities between different fundamental forces and how they all unite into kind of one force. Our theory of literally everything will include religion, and that's because we will use metaphysics to tie an intuitive understanding with a rational understanding of the universe and tie everything together. So in the next two episodes here, we are going to talk about just the physics of the astral realm and then the physics of the particle or the quantum realm. And then we will talk about how to rectify the differences between what are really two opposing theories, how we tie them in as one, and the duality of the universe, the picture of a dual opposing forces that we get from that process, and how it gives rise to the physical world that we experience in our daily lives. That will be the subject of two episodes as well, and then we'll finally tie everything into a nice little bow into what I like to call a theory of literally everything. Okay, so let's dive into the lecture for this time, where we're talking about the expanding universe and what it means that our universe is expanding. So if you remember back to our lecture on general relativity, we talked about how light can only go at one speed, and how it will bend around massive objects, and basically the shape of space-time is not determined, is not static, and it depends on the motion of the things that are within space-time and how that influences light. We talked a little bit about how light will lose energy, how it will shift to being more red on the spectrum if it loses energy because of going around a massive object, because some of its momentum is now going towards the object, and energy is equals momentum and a whole bunch of other stuff, right? So if it loses momentum, it loses energy. There's a speed limit, and light is always moving at that speed at the same rate. Its wavelengths shift, its wavelengths get longer, and it looks more red. Now, the universe on a large enough scale is homogeneous in its composition. That's not to say that every single part of the universe looks the same. The structure of massive bodies like galaxies and how they move around each other, if they're moving towards each other, away from each other, that motion is still random and governed by like gravity and other forces. But if you were to put like a box in any location in the universe and then count the number of galaxies within that box, it would be the same. And so no matter where you look, it's different, but also kind of completely the same. This is what's called being homogeneous or smooth. So you can look at any part of it and it would look relatively the same to you. Furthermore, it's not just the same pretty much everywhere you go, but no matter which direction you look in, you're pretty much seeing the same stuff. And that's another term called isotropic, but it's kind of the same idea, where like if you were to shoot a beam in one direction and look in that direction, and then shoot a beam in another direction and look in that direction, you're basically going to see the same thing. If you wouldn't know which direction you were looking in if you hadn't recorded that information as well as the image that you took. Not only is the same number of galaxies, but they're all moving away at the same acceleration that kind of depends on their distance from us, with something known as Hubble's law. And all of these things together form what we call the cosmological principle. Cosmology is a big scary word, meaning the study of theoretical astrophysics, the study of the theory behind what we think our universe looked like in the past and what we think it will look like in the future. Now, there's something here that's like really confusing and hard to understand called Olber's paradox, which basically is like, so if the universe were, infinite and unchanging and it looked the same in every direction, then pretty much no matter which way you looked, you would eventually find a star. So the question is, why is our night sky dark? Why are you not seeing a star in literally every direction you look? And the answer to that question is that even though the universe is infinite, the light from very, very far away stars has not reached Earth yet because light can only move at a certain speed, even though the expansion of the universe itself can happen faster than light can travel. So nothing can move, like physically move faster than light, but space can expand faster than light. The universe itself can move faster than light, and that's the only thing. And that's why when you look out into the night sky, you're only going to see light from stars that are within a certain distance of Earth, because that's the light that's had time to travel here. And things that are much farther away, we would not be able to see yet. And this means that when you're looking out at these galaxies, when you're looking through a telescope at these faraway places, you're seeing them in the past. This is one reason why we think even if there is other life in the universe, we haven't heard from them, because even if they sent us a message, it would take so long to get here. We just haven't gotten any signals from these places yet. If we do try to look back, super far back in time, we look, in other words, at the far side of the universe, or we look at the electromagnetic energy, the light that we can measure that is the lowest possible wavelength, right? Because that means if it's the most redshifted, by the expansion of the universe, by the fact that in order to travel to us, it has to make up the distance, not just the distance between the two objects, but also the distance that becomes between the two objects as time passes, since all things are expanding. Therefore, the most redshifted energy we see, the most redshifted light we see, that would be the oldest light that we are measuring. The oldest light that we can measure is to about 400,000 years from what we believe is the start of the universe. So if we can't see all the way back to the start of the universe, then how do we know that the universe started with a Big Bang? Well, there are a few ways. For one, all galaxies in the universe are expanding from each other in such a way that no matter where you are in the universe, you could be in this galaxy, you could be in Andromeda, you could be in another galaxy on the opposite side of the universe, and no matter where you are, it's always going to look like you are at the center of the universe, because the center of the universe is everywhere. The universe was initially one point. And where is the Big Bang? Everywhere. Where is the center of the universe? It's everywhere. There is no center because all things are the center. The reason why it doesn't really make sense is because people like to think about our universe as if it were a three-dimensional object. A common metaphor here is to imagine the universe as being the surface of a balloon, and you have two coins that are taped onto the balloon, and as the balloon gets blown up, the coins expand and get farther away from each other. And not only are they getting farther away from each other, but the entire universe is getting bigger. And people think about it that way, and that's not a bad way to think about it. But the reason why people get so confused is because people like to ask questions that don't make sense. Like, what is the universe expanding into? Because they're trying to think about it like the universe is a two-dimensional space expanding into the third dimension of space. But it's not. It's a three-dimensional space expanding into a four-dimensional space. And the fourth dimension isn't spatial. The fourth dimension is time. So what is the universe expanding into? The future. It expanded from the past, and it's expanding into the future. But you can't imagine a place. You can't think of the future as a place that you could go to. And that's why people get confused when they ask the question, well, what's the universe expanding into? If it's expanding, what's on the outside? What's on the boundary of three-dimensional space? Nothing. Nothing. Okay? Nothing is beyond the boundary of three-dimensional space, because it's not expanding into a third spatial dimension. It's expanding into a fourth temporal dimension, which requires you to rethink the way you visualize the expansion in your mind. And it's not something that you could easily draw, but it is something that you could understand if you kind of leave the need for metaphors behind and just imagine what's really happening. And that will make it easier to conceptualize these topics as we keep talking about them. Non-existence is what lies outside of the boundary of space-time. And non-existence is every potential thing that could occur in the future, essentially. Now, the expansion of our universe is accelerating, and that's contrary to what a lot of people believed would happen. So you sometimes see theories and charts that show a picture of the universe where it starts expanding to a certain point and then it comes back and it starts collapsing in on itself. And there are people who believe that the Big Bang happens again and again and our universe recreates itself every time. But that's not really what's going on. And we can tell that by measuring the rate of the expansion and calculating the mass of the universe. So basically, we know that the universe is not going to collapse in on itself. That we know because it's already expanded far beyond the point that it should have. The rate of expansion should be slowing down while gravity slowly starts to pull things back in at this point, but it's not. It's accelerating outwards. And the acceleration is not constant. It is accelerating outwards faster over time. Now, what drives the continued expansion of the universe? We don't know. We are officially at the boundaries of science and what we know today. There are ideas about dark energy. Okay, that's kind of maybe considered to be the energy of vacuums itself. Vacuum energy is something that we'll talk about in the next lecture. Perhaps the way gravity works and the way that objects are given mass occurs in a way that we don't understand. Maybe things look a certain amount of massive when measured physically, but they're actually a different amount of massive when you're not looking at them, in the same way that quantum physics works differently when you're not looking at it, right? So it's possible that there are aspects of physics here that will actually change the theory of cosmology in the future. When people say it's just a theory as a way of dismissing it entirely, that shows a lack of understanding of the way the scientific method works, because the things that build up theories, we do know with certainty. They are things that we can reproduce every time, and everyone can reproduce it regardless of the characteristics of their own existence. If you do the experiment the right way, you do the experiment without bias, influencing your results, then you'll get the same results every time. Okay, that's what science does for us. That's what the scientific method does for us. It allows us to generate truth slowly over time, objective truth. And in this case, the objective truth is that the universe is expanding. We are sure. You can measure it. You can look out in the night sky with your own telescope and measure it for yourself, and it would be exactly the same as the people who have done it in the labs and done all the math already. Okay, you can independently verify this anytime you want. So that we are sure of. Why it's happening, we are not sure of. Dark energy, dark matter, all of these things that are proposed. I read about them all the time. I'm reading about it right now in a textbook that I have from college. This was one of my professors. This is a really good one. Guys, if you like astronomy, this is a good one. And I'm reading about it right now, and dark matter and dark energy and all these things. And I'm sitting here in my head thinking, sure, this could be how it works. This could be how it works. Yeah, it makes sense. The math is, yeah, I get it. But we don't know this, right? So couldn't it work like this? Couldn't it work this other way? And there's no reason to believe that it couldn't work some other way. And there's no reason to believe that, how I talked about how Newtonian laws of physics, the physics of the classical world, like, building a roller coaster type physics, engineering type physics, those are correct on the surface of the Earth. But on the astral realm, on the scale of galaxies, on the scale of solar systems, suddenly you have to add corrective factors. So possibly that's what's going on here. Possibly the science is going to have some corrective factors come into play based on math that we don't have, or conceptual understandings of things that we don't have. Perhaps even observed phenomenon that we don't know about, that we haven't seen yet. So that's why we can't really talk about what will happen in the future of the universe. There are some theories. People will say it's possible that it fizzles out, essentially, and eventually the stars all go out, and there's no more light, and there's no more way to survive without light, so everything just slowly freezes to death. And some people say that the universe will expand so much that even atoms will be torn apart. The space-time will pull the atoms apart and there won't be anything, and they call that the Great Rip. Okay, we have no idea. All we know is that it's not going to collapse back in, because we would be able to see that in the expansion of the universe that we're seeing now. So can't talk about how things are going to end. but we can talk a bit about what it means that things are expanding. All of the things in our universe, all of the galaxies, all of the stars, everything was one massively, infinitely dense point, one singularity. And then it kind of burst out into this hot, soupy mess of plasma and energy like this, and it just kind of slowly pushed its way out. We're going to talk more about that hot plasma mess and what the physics of that really early universe looks like in the next lecture. But once it started to push out more, it cooled very rapidly. At roughly the same rates across the entire universe. So that's another reason why we know the universe was once one thing. Why, if you look outside of time, you see that all things are one thing, okay? Because the temperature of all the various regions of space is pretty much the same, no matter which direction you look. And that's remarkable, considering that the universe is such a complex mess of structure. The filament-like structure that forms because of the different galaxy clusters in different parts of the universe, if you look in any one direction, the independent details of the structure is not going to be the same. It's going to be like snowflakes. No two parts of the universe look the same. But if you count how many galaxies there are, and if you look at other factors, then it looks exactly the same. So it's like completely different, and at the same time, not unique in the slightest, and every part of the universe is homogeneous. Chaos and order kind of just, in this sense, coexist on the astral realm, and they really are two halves of one coin. It's perfectly ordered in a completely unpredictable way. That is the structure of the entire universe, if you look at a map of it. So looking at it from the astral perspective, everything is clearly distinct, discrete objects, galaxies, planets, humans. But if you go outside of time, if you consider the nature of the universe, of the expanding universe, and the fact that the universe is a process and all things are defined by how they change over time, as we discussed in the previous video, then what you start to see is that all things come from the same start. We are, in a sense, one process. We are made of stardust. We are made of the remnants of early galaxies colliding and their stars exploding. And those heavier elements are what have come to form our lives and our planets and everything that we know. And so we really are one thing. The universe, everything is one thing in a sense. It's one interconnected process. And that is what cosmology metaphysically informs us of. So the science stops with the universe is expanding, the expansion rate is increasing over time, so the universe is not going to collapse. And what is the universe expanding into? Nothing. It's expanding into the future. It's expanding into the fourth dimension. The expansion of our universe depends on certain variables, things that we call cosmological parameters. Okay, and these cosmological parameters dictate the nature of our expanding universe. That's the science. What does the science tell us? Science tells us that we are one interconnected process, that there is energy everywhere in the universe, and that we can see that energy or hear that energy if we turn on our radios and just tune in. So I hope you found this helpful. Comments are welcome. Please put them here on this video or shoot us an email at covenantoftheopenmind@gmail.com. If you haven't already, join our community. Find the link on our website at openmindedpath.com. And from everyone here at the Covenant of the Open Mind, blessed be.